we're going to go over rate law and reaction order. So this has just been an introductory video. So if we have a reaction here, with the lowercase numbers being the stoichiometry, we can describe the rate as K with the concentration of the reactants. If you note, X and Y are reactant orders, they're not stoichiometric coefficients. So you can get reactant orders 1, 2 or 0, and to determine the reactant orders you need to know the rates and the concentrations and do different trials to see how the rate is changed. You can't get the reactant order from the equation. So to determine X and Y, we have some experimental data here as an example. So you have carbon monoxide, oxygen and carbon dioxide. We have stoichiometric coefficients, concentrations and rates, and 3 different trials. We're going to determine X and Y, so these two, and the units of K, which you have to do for every example because the reactant orders could be different. So we have the form rate equals K CmX and O2Y. And X and Y could be 1, 2 or 0. If you know the laws of indices, then the concentration is to the power of the reactant orders. So anything to the power of 0 is 1. So we can cross it out if one of them is 0. So if we look at carbon monoxide, as the concentration in trial 1 and trial 2 are the same, there's a difference in the concentration of oxygen, it doubles, and we see what the difference is with the rate. So for reactant order 0, there is no change on the rate. For reactant order 1, there is the same change, i.e. if you double this, then this doubles. And order reactant 2 is the change is exponential, i.e. if you double this, then it's, i.e. like if you multiply this concentration times 2, the rate is multiplied by 2 to the power of 2. So if we try and find out what the reactant orders are, we've seen that carbon monoxide is the same concentration from trial 1 to trial 2. In oxygen it's doubled, so we can write multiplied by 2. And here 0.04 multiplied by 2 is 0.08, and we have 0.16. So we know from here that the rate order for oxygen is 2. So Y equals 2, because 2 to the power of 2 is 4. 4 multiplied by 0.04 is 0.16, which by definition is order reactant 2. So now that we've identified the rate equation looks something like this, we can identify X. So for this one, the concentration of carbon monoxide doubles. For this one, if we look at trial 1 and trial 3, the concentration of carbon monoxide doubles and the concentration of oxygen stays the same. So we can write here, we'll see the effect this has on the rate. So in trial 1 the rate is 0.04, but in trial 3 the rate is 0.02. So if we double this and this doubles, they've changed by the same multiplier. This means by definition it's order 1. That means X equals 1. So if we write our rate equation, rate equals K. We know X is rate order 1. Or you could just leave that out as the concentration by itself means 1. O2 is there.